Hey, hey Tim. I think and I think I did. I sent you a message on Facebook. I'm looking to put together a hotel demand forecasting and price optimization system, and I want to do this. It's intended for small hotels in Greece. I've got a company in Greece, contract or a little consulting company in Greece that I'm working with. Excuse me, and they're wanting to market to small hotels there. Tourist industry in Greece is big industry. Anyways, um, I know there's systems out there to do this. Opera has a system. I'm not talking about Opera Solutions. I'm talking about Opera. There's another company called Opera that does price optimization for hotels, and I'm sure there's some competing companies as well. I don't even know the names, and I don't know how they work. I swear, I've never even thought about this type of stuff before. But this is interesting stuff. And I know you're the whiz, and so I would like to get your opinions, your ideas, your experience, and I'm gonna stroke your ego here by saying that you are the whiz, you're the one who knows everything, and I'm the apprentice here, looking for your advice. Anyways, just so you know, I've put together kind of a whiteboard of things that I think of how I want to approach this, and I just want to get your opinion on this. Hold on. Okay, here's my whiteboard. Let's start off at the top. Basically, the title is Hotel Demand Forecasting and Price Optimization. It's actually two separate parts. The demand forecasting is important because that's one model, and that's going to feed into the price optimization, which is another model. So it's actually like two separate models. The demand forecasting will be determined by the historical data and current data that are being fed into it. The historical data will help determine the model. The current data will output the current demand. The price optimization will need that model, plus it also needs the historical price and demand data in order to train its model and the current data to get its current price optimizations get the current optimized prices, which is the output here, the optimized price. So this is kind of just the high level of the system. My variables, well, anyways, let's talk about demand forecasting right now. The variables that I see that are important: the reservation day of the week, holidays and seasons, also any planned community events, although I can't really depend on getting this data. Also, competitor vacancy. I can't really depend on getting that data. However, there's a proxy for that, and the proxy for that would be the velocity of booking. So, for a particular date, if I see the velocity of booking is increasing, that's an indication we've got a planned community event or we've got not a lot of vacancy with our competitors. Okay, so velocity of booking could be a proxy for these two. The immediacy of the booking, the more immediate the booking is to the or the more immediate. There's two dates. There's the booking date and the reservation date. Anyways, the closer the booking date is to the reservation date, which is the immediacy, the higher the price. Then there's the net price, and can't remember what I was going to say about net price. But anyways, I drew a little relationship here. Not that important. Um, how to measure demand, and this is important for a specific date. There's two things that we're going to want to look at in measuring demand, and probably it would be both of these plus an additional ratio of the two. First one is the booking quotes per day. So when someone logs online, or not logs online, but goes online and tries to look at the availability of making reservations for a hotel, that's the booking quote. Okay. If they actually go ahead and reserve the hotel, then that's a booking made. So what we're interested in knowing is how many booking quotes per day and how many bookings were made per day. Um, this ratio of number of made to quotes is very important, and I'll explain why a little bit later. But basically, it's helping us predict the probability or the rate of booking, and the rate of booking is important. We need to know that because we want to make sure that it falls within a certain range. Anyways, talking about that range, this is it right here. So this is kind of how I think it should work. This kind of came out of my head, but I'm betting that this is what hotels do. Here is on my y-axis my bookings. This is my full occupancy, 90%, 80%, all the way down to 10%, 0. This is my reservation date. So at reservation date, I should have a full occupancy. In this scale here is the number of days prior to the reservation date. And notice that it's not linear, it's actually logarithmic, because it makes more sense to be logarithmic and not linear. But anyways, because of that, this line here is my ideal booking rate. And that line there would be defined by this formula here, which is bookings is equal to some booking factor x times the log of the days prior to the reservation date. D is this right here. So x is basically the slope of this straight line on this logarithmic graph. Okay, this to me is key. Okay, this is the ideal booking rate. Okay, now why is it key? Because what we want, the whole reason of measuring demand, is that if the actual bookings is about the same as the booking factor, then we keep the same price. Meaning, if the actual bookings, as we getting closer to the reservation date, approximately follow this line, then we want to keep the same rate. We're doing fine. If the actual bookings is significantly faster than the booking factor, faster meaning we're getting more bookings earlier in time, so it's going up here, then we're going to want to raise the price. So if we raise the price here, it'll slow it down and move that curve that's up here, move it down to this line right here. Okay. The next one is if it's significantly slower than the booking factor, then we would lower the price. So if it's slower, then it's going to be coming down here below here and then up. And if it's down here, then we're going to want to lower the price to bump it up so that it follows this curve. Okay, so that's how we determine whether we're going to lower the price, raise the price, or keep the price the same. It's all based on this demand, and this is how we measure demand. All right, so the price optimization, different things that can go into this. I think the most important thing is the actual demand, but some other factors that we can take into consideration is the immediacy of the booking, but then again that follows this demand because this takes into account the immediacy, so that's kind of taken care of right here. The current vacancy for the date, well, that's kind of taken care of by this curve as well. The next one is the recent booking rate. Again, that's taken care of by that curve. So all those first three are taken care of. Business rules. Now this is important because the hotel may have certain business rules like a max price, a min price, and if any subsidies. So for example, if they got restaurants as part of the hotel, or maybe they have a gaming, if it's a casino resort, then the gaming revenue or the restaurant revenue can subsidize the actual hotel. So that needs to be taken into consideration. But the big thing is the actual demand, and the demand helps. As long as we follow this curve, I think we can optimize the price. Now, something that I noticed here that I believe is the bookings made per quote ratio. That's the ratio of this bookings made per day versus over the quotes. That ratio is correlated to the vacancy. So as vacancy goes down, this ratio should go down also. And this is controlled by raising the price. Okay, so you can think about that. It's I don't know, it's semi-important. But then we got here, I just threw in some graphs of kind of how I think things should look at price versus vacancy, and then this is that ratio of the bookings made to quotes versus vacancy. But in the end, the optimized price, and that's what I wrote down here, the optimized price is that which helps us maintain the booking factor. So I'm going back to this, as this is my guide for whether I determine whether we raise prices, if we're going too fast up here, or if we're going too slow down here. And how much we raise that will be determined by how fast we're going up, and how much lower we make the prices, how much slower we're going here. And as we get closer here, those prices, can tend to normalize. Here if we're going up really fast, we raise prices that'll bring it back into here. I don't ever think we would never want to lower prices. There is a possibility what could happen. You raise prices and then it goes straight across and it gets in the lower part here, and then we'd lower prices to bring it back up. So this area, this triangle here in the bottom is where when we lower prices, this triangle here in the top is when we raise prices. The only time that you would ever raise a price and then lower a price is if it crossed over into this other triangle. Or if you were lowering prices and then it crossed over and went up in the upper triangle, then you raise prices. Yeah, I could see that happening. You start off too high, and as you get closer, you end up, lowering the price. You lower it too much, and then you got to raise the price to get it back on the line. So, yeah, I could see it kind of maybe going back and forth, but not a lot. So that's my idea. What I'd love to do is get your opinion on this. Like I said, you're the whiz. I'm the apprentice. I would love for the master to give me some direction. Thanks.